Welcome everyone to our afternoon session, our afternoon in Eastern Standard Time or Daylight Time. We have a great slate, a very full slate of speakers about metadata, a favorite topic I think of many of us who engage with Dataverse. So we will go ahead and get started. We do have a chair, a moderator, and a note taker for this. So we have lots of support, as well as, of course, our colleagues at Harvard helping keep all this going. So please put questions in chat, or if you have any technical issues as well. And we are going to begin. We have a slight change to the agenda. Our first speaker today is actually going to be Wim Hugo, speaking from the Data Archiving and Network Services in the Netherlands. And make sure I'm working off the right list. And Wim's topic is, where does metadata end and the graph begin? So we will go ahead and turn it over to Wim.
Okay, thank you. Let me just attempt to share my screen. Hope you can all see it now. Okay, so this is more of a high-level talk, I suppose, because as you would know, and as Slava Tikhonov would be conveying to you in the presentation to follow mine, Dans has done quite a bit of work that is now part of the Dataverse community edition to integrate semantic artifacts into our metadata. While this is, of course, extremely useful, the question started entering my mind on how far one should go with this integration of external vocabularies into one's own metadata collection. So today's talk is a little bit about the perspectives that I have found so far. And of course, it's an ongoing conversation. So the metadata landscape, as most of you here know very well, is complicated. There's a large number of schema. And to my mind, at least, they focus usually on one of three types of scope. The one is very general, so it's applicable to any kind of content, such as Dublin Core and so on. Or it can be type specific, and there's probably two subgroups there. There is metadata that is specific to a certain kind of research output type, such as code meta for code, or data site for data sets, and IGSN for specimens and samples and so on. And then there are also formats and schema that have to do with a type of type of output that we're looking at, such as ISO 19115 for geospatial data and so on. So these are type-specific metadata schema. And then there are, as most of us know, also domain-specific metadata schema, such as EML for ecological data, or Darwin Core for biodiversity, DDI, and so on. So this complexity means that the wider we cast the net in our catalogs, the less correspondence and simple mappings there will be between these different metadata schema that we're trying to accommodate. And this is a subject of a different conversation, but that we're also involved in. But today we're focusing rather on how we integrate these different schema with external semantic artifacts. If we look a little bit deeper, then I'm trying to map all these different metadata schema generically onto a representation that indicates to what extent it is either general, format specific, or domain specific, and a combination of those. Dataverse, for instance, tends to be able to accommodate domain-specific metadata, and while it is possible to also include format-specific metadata, that's not done so often. Geospatial data maybe being an exception there. Now, when we get to how we then expose our metadata to external semantics, we can categorize these external semantics in terms of their sources. we typically have standard or controlled vocabularies. Those are often created by the metadata schema or standards themselves, or they are agreed by the community. There are registries of permanent identifiers, most commonly for entities such as researchers or institutions, but also sometimes for concepts. So people might create registries of things like data types, for instance, and each of them would have some kind of persistent identifier associated with it. And then in general, there are graph-based or other linked data, open data resources that we can access. So to return back to the question of where metadata ends and where the graph begins, then I'm making a proposal essentially that we should consider this quite carefully and try and determine what the criteria might be or the design considerations might be to decide whether the external semantic artifacts information should be included into our metadata or always retrieved on demand or on request, and to what extent these things should be permanent and to what extent they should be transient. So if we include semantic artifact references into our metadata, we have to consider that it might get out of date. And Slava, no doubt, will touch on this in his presentation because caching provides a technical workaround for this problem to some extent. The second consideration for me that is actually much more important is that we need to be able to index metadata differently for different end user communities. And not all communities are interested in the same data that are interested in the same data sets are necessarily going to use the same ontology. So this means that it is probably not advisable to include the community or domain-specific semantics too permanently into our metadata, because it is going to be different depending on the end use that metadata is being put to. And then the purpose of these links to external semantic artifacts may also determine how we handle them. But generally, it is one of three classes that, as far as I can see, the one is to standardize and disambiguate free text information to the maximum extent possible. So linking them up to controlled vocabularies or other graph-based resources. Add additional context to a metadata element. So that for that example, one can think about something like a license where we have a persistent identifier to a license that's applicable to the metadata record. But all of the rest of the provisions of that license can be found in a registry of licenses, for example, and we don't have to include it into our metadata directly. And then also to use these semantic artifacts as a basis for enhanced indexing. So those are the three main uses. And then while considering that not all communities would be interested in the same enrichment or indexing, and the fact that things might get out of date, I think those are the main design considerations to decide how and where the metadata ends and the graph begins. So I started elaborating some proposals. This is just a schematic representation, but we probably don't have much time to go into it. On the next slide, there is a table that is maybe slightly simpler to engage with, where we're basically saying that depending on whether things are free text elements, spatial references, date and time elements, or controlled vocabulary elements in a number of classes, we have an indexing requirement that we have to satisfy, and also an additional contextualization requirement that we have to satisfy. And I've written my ideas at the current point in time on how one should accommodate these requirements in terms of metadata, whether it's stored internally or externally, and whether caching applies, And if caching applies, whether it should be done server side. In other words, the caching is similar for all of the end users that we think we are going to have, or whether it is client-side caching that can be tailored to the end user's context. So that's where we are in terms of thinking about the broad concepts around the border between metadata and semantic artifacts. There are some special cases that I've documented in the rest of the presentation, which will be available to you, but for which we don't have time at all. And that is that spatial, temporal, and topic coverages describe the when, where, and what of the content of a digital object. But we can, of course, specify this in absolute terms, such as a location on Earth or a position in space. And these can then be mapped to external vocabularies that contextualizes it depending on the perspective of the end user. And what I'm saying is that these typical mappings are highly dependent on the domain, on time, on cultural conventions. And our proposal is to actually exclude them in metadata and contextualize them via indices based on external semantic artifacts. Okay, so to conclude, I think we're at the point, certainly in the European Union, where the availability of semantic artifacts will improve significantly, and where there is major investment in infrastructure to support this underway. In Europe, there are at least 2 interconnected projects that have just started, where DANS has a role in both, called Fair Impact and Fair Core for EOSC, that will define portfolios of best practices and implement operational EOSC services for research graphs, for PID graphs, and for brokering platforms to register and describe semantic services and the mappings between them. So all of this is underway, and I think we need to start thinking about how we are going to implement and integrate them into our metadata repositories and catalogs long before they become available, because then we're ready to make the most of them when they arrive. So thanks very much. As I say, it's almost throwing a pebble in the pond kind of situation, I would think. And I would welcome comments and guidance and interest from anybody that wants to contribute to this thinking. Thanks very much.
Wonderful. Thank you, Wim. We do have time for questions if anyone would like to pop theirs into chat or the Q&A. Or if you'd prefer to speak, you can raise your hand and we will give you the ability to speak in the Zoom. Right, looks like we have some raised hands.
So we have a raised hand from Jim Myers and Paul Boone.
There's one from Jim. All right. We have a really good turnout. I'm trying to locate names.
Sign up there.
Somebody already got to it.
Yes, Dwayne is getting to it.
Okay. Thank you, Dwayne.
No problem, Jim. You can talk.
Can you hear me okay?
Yes.
Testing, okay. I somewhat of a comment, but the question of where does the graph end and caching, that's something that we put into the external vocab mechanism to start with. That the database really considers it's only doing the ID, but the ability to cache some subset of the graph that we want to have in metadata exports is kind of in there. And the idea is that stuff is indeed just cached, and it's for convenience because it's usually just some set of the even larger graph you could keep going on. So this all, sort of makes sense.
That's exactly right. And what I'm thinking about is that if the context provided by that subset of the graph is end user specific, then the type of caching potentially has to change slightly. Okay.
Okay, Paul, I also gave you the ability to talk.
Yes. Hi, Paul, also from Dans. So I can always ask Wim later on. But my question is, if you get the metadata, initially you have somebody creating the data set, adding the metadata, or you are just stuck with the metadata you have, which is probably specific for a certain domain that the original creator was part of. So then you would probably have to preferably automatically transform that to something that is better for transforming again to some other domain. For instance, we have coordinates in a coordinate system that only applies to Holland, to the Netherlands.
Yes,
and that would
exactly.
be difficult to, you would have to change that. Well, not change it. I think you have to always keep the original entered metadata. But
Yes.
what are the thoughts on this? Are we going to specify what the optimal metadata types are, or is there any idea?
Yes, so there is some thoughts about this later on in the presentation, which I can share directly here in the chat once Slava is underway. So it is exactly that, because for some of these coverage type metadata elements, is certainly location and temporal coverage. You want to make that as culture and domain independent as possible, almost like a universal definition of time and place, and then map them to country or domain or discipline or culture specific interpretations of what that means. So for instance, in archaeology, as you may have picked up already, but the let's say the ages assigned to a specific time in the past in the Netherlands, for instance, is different from what it is in France. So if you are a French researcher, you would want to index the temporal coverage of a metadata record differently from potentially one that is located in the Netherlands.
But I would always want to keep the original entered metadata. Also, because it contains actually more information. As exactly that information that you are going to remove, like the domain specificness, or maybe something about the period in time that this was something that people used to specify this. So there's more information than just the numbers. So
no, so I'm not advocating that we remove the original metadata or not apply it, but I'm just thinking about how to arrange this in a world where a lot of the information that we want to apply to our metadata is dependent on the perspective of the end user. I guess that's sort of in summary what I'm trying to propose.
Okay, yeah, great.
All right, I'm going to suggest if there's more discussion, we'll move it to chat. I think Wim will hang in as long as he can, but we did move him up first because he does have other commitments in his time. So thank you very much, Wim. We'll move on to our next presentation now from Slava Tikhonov, also at DANS, speaking on behalf of colleagues about their project, which is titled Flexible Metadata Scheme Support for Dataverse. So I think very much related.
Okay, thank you very much. So we just heard theory, and now we're going to learn practice. So I'm going to talk today about flexibility in metadata schemas and standardization in Dataverse. So we have project called Claria, and this is common lab in research infrastructure for arts and humanities in Netherlands. And the functionality that we created is being used in another project called Odyssey. And this is another infrastructure for social sciences and economic innovations. So just briefly, of course, you probably know what Dance does, but just to give you impression, the complexity of tasks that we have. We're dealing with a lot of research communities, bringing different data sets and described differently in different formats. And one of them is called Clarin, and this is Common Language Resources and Technology Infrastructure. And Clarin has own format called SIMD. And in SIMD, and it's also international format, it's been used in Europe a lot, particularly in Norway, for example. So in this format, we have XML with hierarchy, and it's quite difficult to do processing of structure in this hierarchy. And we need to search, we need to build a mechanism to search inside of those metadata fields. So the problem on generic level. So usually communities want to find their specific resources. So they have own control vocabularies, they have own metadata schemas, and from other side, we as archive, we want to build a generic solution. We want to allow people to search across of all instances of all data repositories. And of course, this is a challenge, and we're trying to figure out possible solutions for that. So now we started to work on semantic mappings, and we created API, and is a kind of negotiation between those two perspectives.
Slava,
So,
I'm sorry, Slava, there's something blocking the, there's a huge black block blocking most of your right screen of your presentation.
You don't see my screen or what?
Okay, it's gone.
It's fine now.
Okay, sorry for that. I don't know what happened. Okay, so you can see my slides about semantic interoperability, right?
Yes, they're perfect.
Yeah,
now.
okay,
Thank
okay,
you.
I will continue. So we envision situation where we will have thousands of Dataverse instances, or probably other data repositories, and we are, as you know, working on this. And recently we make release of Archive in the Box. So now every institution or university can just install Dataverse out of the box and start to deposit data. So basically, what we do, we are allowing semantic interoperability on the infrastructure level by providing this Archive in the Box for everyone. And we're also working on two different approaches. So first approach is based on crosswalks. So we're trying to map metadata across different disciplines. And second, of course, you know that we've integrated external control vocabularies in a collaboration with Global Dataverse Consortium. So before, situation was quite simple. So we had repositories like Dataverse NL with a lot of partners depositing data in the same instance. And what we want now, we want people to run their own Dataverse in their place, and it will create network of Dataverses. And we want everybody just to share data in standardized way. Okay, so the problem of our specific case with SIMD, so we have old system called Easy, and of course we are not able to get all metadata fields from every discipline. We are just basically taking generic description containing Dublin core, so it's title, description, keyword, and some other fields, and all other records are stored as files in this system. And the idea that everything should be transformed and should be deposited in Dataverse, and all fields should be recreated in Dataverse as custom metadata schema. So a conceptual approach for this, as probably you know, in August of last year, it was very nice release of Dataverse Semantic API, where Dance was involved, and we're using this Semantic API for own migration from Easy to Dataverse, and also external control vocabularies, which was created by my group and also integrated by GDC. This is kind of first step, and we are moving in this direction now. So just to give you impression about our pipeline, it's quite complicated. And also you can see two blocks. So first block is in red color. So it's basically semantic services. This is how we see mappings across metadata standards. And in green block, you see control vocabularies and mechanisms that will allow to query control vocabulary services like Cosmos and get back values and enrich metadata. So there is proposal, it's called SEMAF, and this is a proposal for a flexible semantic mapping framework. And Vim is also co-author of this. And there is prototype solution that we implemented to see if it's possible just to create semantic mappings and map any kind of input data to knowledge graph, and basically to get possibility to do processing of any kind of information coming to the system. So this is coming close to the implementation. We started to use DCAT, and DCAT means data catalog vocabulary. We're also using SCOS, and this is kind of glue to model thesaurary-like resources with simple relationships. We're also trying to load all SIMD properties and attributes, and we're building knowledge graph of it, out of it. And we're enriching this knowledge graph with concept theories coming from various control vocabularies, like Cosmos or Wikidata or some other solutions. And we're using different format data serialization formats for integration with different systems. So for example, if you'll get some metadata in a knowledge graph, we can quickly serialize and produce JSON LD suitable for Dataverse, or Turtle suitable for Jena Fuseki, and this is triple store. And we can also feed any linked open data framework with any kind of RDF, because this is already in knowledge graph. So complexity of SIMD, and I already mentioned, it's really not simple to map fields from SIMD to something like Dataverse metadata schema. There are repeated attributes, also repeated elements, repeated blocks. So if you want to do it programmatically, it's very difficult task. But if you want to read everything and convert to knowledge graph, that's possible. And in further slides, I will explain you how. This is second part about control vocabularies, and functionality that we implemented is already helping us. So basically, you can search in Dataverse for some keywords, and it's linked to some frameworks like Cosmos. It's getting back list of concepts, and after concept will be selected, it will do caching of this concept content in Dataverse, and this is how you can get translations of this concept, and you can search on it. So this is already implemented, and that's something we already started to use in our work as well. So again, knowledge graph is built on top of Dataverse metadata schema, because we need to know everything about every field, about all relationships, about hierarchy. So as a first step, what we do, we're just loading all TSV files with metadata schema with all fields, and we are recreating all hierarchy, and it's now stored in knowledge graph. And from right side, you can see, for example, keyword block, and keyword has the keyword value, keyword vocabulary, and keyword vocabulary URI. And all of this information could be just extracted from the knowledge graph quickly, and we can fill these appropriate fields from our input metadata and put it back in knowledge graph. Okay, so just to make it even more practical, so we're dealing in a few projects with a lot of data providers, and they're bringing data in different formats. So we created this, we created service that allows just to provide supply semantic mappings. And what it does, it basically producing JSON LD, which is suitable to upload directly to semantic API of Dataverse and create data set. Also, CMF can produce original Dataverse format, which basically means that you can run Dataverse without even having Dataverse. You'll get exactly the same format as Dataverse is producing after you're exporting data set. But all of that is powered by knowledge graph. So just to give you an idea how it works, so there are two different parts of CMF. First part is called CMF template, and why you need template. You know, data coming from different data providers sometimes is not containing all fields that required to create data set. For example, subject field, you don't have that. So we decided to create this template and put all values that should be filled by default. Even if they're missing in original data set, still it will be created and will be put in knowledge graph, and after it will be serialized in JSON LD that will be deposited to Dataverse. And second part of this second block is basically from right side is corresponding to XPath that could be mapped to any dataset field. Like you see, there is DS description, this description value, and topic classification and other fields. So by taking this, our mechanism knows that if there is this description value, it needs to find in knowledge graph all relations. It needs also to find parent and to fill this as one item with all available values. So this is example of transformation. So CMF does transformation just like, well, in a way, it can be considered like magic, because what it does, it's just getting all stuff from knowledge graph representing citation block, and after it's filling this metadata coming from input file, and it just does the transformations. It's also getting all links from original metadata schema, like title, because title is mapped in this spreadsheet to DC terms title and also DC term creator. So all of that is basically manageable. If you want to create different mapping, you can just change this in TCP file, upload again to Dataverse, and after you'll get completely different representations suitable for different community. So this is also covering the question from Paul, how we can do it in a way without changing metadata. We can change semantic mappings, and we can change linkage to other disciplines, and it just works. So the same data set, the same data set is presented here as a list of triples, and this list is basically suitable to upload to any triple store and just run Sparkle queries. So I specifically took this example because it's in Dutch. We can also do on-the-fly translation from, let's say, from Dutch to English with different properties. And from this moment, we can query in English, and we can find all the information stored in our knowledge graph. Okay, so just to make it even more interesting, I started to think how to apply machine learning for non-structured information. So like we mentioned already, we have a lot of free text. So the idea is just to apply machine learning frameworks like Spacy and extract all named entities like person name, geolocations, organizational names, dates, and you can also train to extract custom labels. And all of that could be also linked to own ontology and could be filled with semantic mappings, and also can become part of Dataverse metadata. And yesterday we had
2-minute warning.
Okay, so yesterday we had. Sorry?
I was just warning you about the 2 minutes. Sorry, some lag.
Okay, no problem. So this is example from the project that was presented yesterday. It's COVID-19 Museum, and this is practical implementation where we just started to track media streams. We started to recognize news. We are defining structure of news, and we're applying artificial intelligence and machine learning to generate keywords and other fields. So all of that is filled automatically and stored in Dataverse. So in principle, you can see now it's in French, but also after translation, automatic translation, it could be searchable with English and other languages. So what we can do with it, and this is really amazing functionality. We can also take all data sets from Dataverse network, and by the way, not only Dataverse network, we can do it with DSpace or Zenodo or wherever, and we can enrich, we can query external control vocabularies, and we can read it in knowledge graph, and we can enrich metadata with links to those external control vocabularies and put it back in Dataverse. Of course, not in the original Dataverse, but the way how I see it, we're kind of creating metaverse for Dataverse. So this is another Dataverse instance running somewhere. It's keeping all persistent identifiers, but it has much more information, and it has also knowledge graph with all links. So here you can see from right side, we just took some random data set from Harvard network and enriched with links to Wikidata. And we can do it for any kind of format now. So just lessons learned, just quickly. So communities want to find very specific resources. They think it's not possible that archive can make search on all instances in generic way, but it seems it's really possible. So we provided a solution for Cindy problem, but now it's being taken by other projects. So the second project called Odyssey, and they started to use the same approach. They started to map the metadata fields using semantic mappings very quickly. So basically you need minutes instead of hours or days to recreate semantic mappings and create a data set. And it's all applicable on European level, and I believe even on global level. So in the future, all repositories might become nodes in large searchable knowledge graph, because we are also supplying next to knowledge graph Cosmos, which contains a graphical endpoint. And also you can run Sparkle queries, so you can just directly search in knowledge graph. And part of this future will be automatically supporting semantic enrichment, I believe, in the future. Of course, there is a problem to keep provenance, because we are basically getting stuff from all of the places. But still, I think this is kind of next task that we should take a look. So there are links, and I also will share my presentation. So if you're interested, just ask me or just contact us, Dance. And yeah. Okay, thanks.
Terrific. Thank you, Slava. I see we already had one question in chat about a specific link, but we'll make sure your slides with all the helpful links are shared out. I think we have time for maybe one question. If there was anyone who wanted to raise their hand and be unmuted, or just ask in chat. Yeah, our Dan's colleagues just blowing me away again with all the work y'all do.
Or it was not clear, or it was terrific, like I said.
People might need time to process still. And if you haven't followed the link to the community notes, Julian is doing a fabulous job keeping this populated. If this is making your head spin as much as mine. So maybe we'll go ahead. Oh, sorry, Slava.
In terms, if you want to see practical implementation, so you still have a chance to visit session today, where we will present COVID-19 Museum. Basically, it's using those principles, and this is how we are getting stuff inside, coming from different sources, from different disciplines, from different locations, from different countries. So it doesn't matter from where it's coming. It's kind of Google that just does processing of everything and just depositing in Dataverse. So you are welcome to join session tomorrow.
There's just a question from Dorothea in the chat. They seem to be doing semantic enrichment manually in Stuttgart, and she's asking how do you do this automatically if it's via machine learning?
Yeah, we are training models, and we are able to establish relationships. Also, there is really cool development called GNN, Graph Neural Network, and we can also train on subsets of knowledge graph already, and do recognition and resolving of concepts. So if you're interested, just contact me, and I will tell you more how we do that.
Okay, great.
Okay,
so thank you again, Slava. We will go on to our next speaker, Oliver Vertuk. Will be talking with us about metadata, of course, the Hermes project, metadata-rich automatable research software publication. So, Oliver?
Yep, thank you for the nice introduction, Jen. I'm going to talk about, like announced, about the project Hermes, which might be familiar from last year's Dataverse community meeting, where I announced that we successfully managed to get funding for this project by the Helmholtz metadata collaboration. And we joined from the DLR, HZDR, and Forschungszentrum Jülich, which where I am working at. And we grew a bit in terms of team members, and things are going great so far, I think, as we published some things, and I'd like to report first of all on what this is all about, and then go ahead and tell more things about what we see as problems and obstacles in Dataverse as it is now in terms of research software publications. So what is Hermes from a very high level view, like a bird's eye view from 10,000 kilometers away? It's generating a payload of software and metadata and putting that in some place where, which we call publication repositories. So this could be Dataverse, but of course this could also be things like DSpace, Zenodo, Figshare, whatever. It's quite flexible in that way. So when we're talking about research software publications, why is this important at all? And I've recently talked a lot about why we should put the same effort of research data management and fostering that also into the field of research software engineering. And you can also watch a YouTube video of some of these talks I gave. I'll share my slides also as PDF, already uploaded them. And every time you'll see these blue links in here, these are all clickable links and they are all over my slides. So please follow them for more information. So publication of software is important for things like referenceability and reproducibility, because when in a researcher's life, you most likely do certain analysis of like experiments or reproduce experiments. You'll take together different results from different experiments, analyze them again, and all of this involves some kind of software, be it software you write your own or you're reusing because someone else is writing a library for, let's say, the neuroimage community. So let's see how this fosters in reproducibility. Well, you might need to identify which version of the software you're using. And also, you might want to be interested in creating visibility for research software engineers, because in today's scholarly output system, you'll just be rewarded for text publications. And maybe these days you'll have credibility for data publications, but software is just another very important output of scholarly communication and scholarly research. The referencing is important for knowledge graphs and reproducibility, as already said, and it might be nice to create a GitHub repository and drop your code there, but that's certainly not enough. Like, you want to make it more fair. You want to have fair data, and so you want to have also fair software, which is also why the RDA has recently dropped the Fair for Research software specifications. And where would you do that, such a thing like a publication of software? There are plenty of options, and let me stick out here with the one option we most likely are most interested about, as this is Dataverse community meeting, which would be repositories. Repositories are great when you're trying to create publications for versions of software. And this is not meaning you're creating a Git repository at GitHub or GitLab or something like that, but you want a DOI, you want metadata and all this stuff, and so you're with data repositories. Of course, all this means more work for researchers. And as we learned from our experience, there is a rising interest in software publications, but we need to improve the workflow for scientists to make it easier to get there. So this is one of the main reasons why we came up with Hermes and this project. Hermes has two sides. It is, first of all, and the larger part of it is about the sending side. Like, you want to collect the research software, you want to collate the metadata, and then create a deposit. You'll be faced with some version control repositories, hopefully, otherwise you're on your own. And that is then used to create a package, a deposit, which can be dropped off, launched and dropped off at some kind of publication repository. I'm not going into much detail about how this side of Hermes is working because, well, we have a concept paper, which you're happy, which would be great to, if you read it and give us feedback on it, if you find anything that doesn't seem right. There have been some talks, and you can also watch them on YouTube or just look at the slides. And also the workflow is developed in the open on GitHub. So please tag along if you want to follow us on the development of Haggis, which will be the actual workflow implementation of Project Hermes. So what about the receiving side? The receiving side is like Dataverse, MyCore, Invenio RDM, and many others. And we will support those by having an extensible platform. Like if you want to have another target repository, go ahead, write an adapter, you're good to go. The initial support will be for Dataverse and Invenio RDM, which means in practice, Zenodo. So when we are aiming for depositing research software into these platforms, we need to make sure that these platforms are actually capable of accepting that and exposing all the metadata we just collected. And so this means, first of all, any target platform needs to make sure it has proper software metadata support. And that range has a very great range of consequences in terms of what a repository needs to implement. Like you want to have the intake ready to retrieve the metadata, software metadata. You want to register the software as a software with PID providers like DataSite, and so on and so forth. You want to have, most likely as a part of the depositing process, something like a curation, like you want to break the depositing pipeline when some kind of metadata is missing. So you need machine readable metadata requirements. And of course, like the Fair for Research software, findability requirement 1 says you'll need a concept PID and a version PID. So every version needs a persistent identifier, and also the concept means like the software as a whole thing to when you want to cite that or reference it. Of course, you'll need software license support because Creative Commons isn't sufficient for this. And you'll need to be able to distinguish, for example, in the UI or in an API response, etc., between data and software deposits. It needs to become clear which is what. And you'll, of course, need to distinguish between those also in terms of the metadata support. Like you want to know, can I actually offer a code meter download here? Or is there anything that makes, or doesn't this make sense because, well, this is just a data set. There is no code meter here. So let's make this happen because, well, Hammers has a kind of secret second side. It's not just about the sending side, it's also about creating the support in our initial target platforms. And that'll be up to me for the Dataverse side. And HZDR has an Invenio RDM-based platform for their publications. So they'll be looking into how to make this happen in Invenio RDM. Let's take a hopefully quick and closer look on the Dataverse planets. Actually, I don't think we're ready. We have a lot of stuff that is missing right now from Dataverse. And the only thing that might be in there is like, you could add a metadata block and that would appear in the UI, but that's more or less it. We don't have a lot of support for the other things, like we don't have software licenses out of the box. We don't have PIDs per version, etc. And of course, this is also very heavily related to workflows and workflow depositing, just as Mahmoud lined out in one of the former sessions. I think he's going to repeat that tomorrow. And it's might also be about storing reproducible environments in the future. This is not a hot topic right now, but this might come up later. So what would be low-hanging fruits here? Of course, adding another code metadata block is one of the first steps to take. And there's actually a long-standing pull request, and it hasn't been received much love, but I'm going to change that very soon. So we hopefully have out-of-the-box code meta support, at least in terms of a metadata block. Another low-hanging fruit here would be writing an exporter. So I'm going to create a pull request for that, and so on and so forth. Another thing that would also not just be beneficial for software as a deposit, but also for data and workflows would be the versionability or the persistent identifiers for versions of a data set. The requirements to access requirements of a Dataverse collection and what metadata needs to be sent when you're depositing is also a long-standing pull request, totally independent from software, so it's also beneficial for data and workflows. Another thing I just recently came across is that we might be it might be handy to have an XML Rdf output of the metadata we're providing here via our OAI PMH. So it's making all the metadata of custom metadata blocks, etc., harvestable, which would also be great when you want to harvest, like, give me all software you have indexed here. And of course, well, software licenses types might be added. There's also already an issue about this, and a discussion is going on here. The not so easy task would be those things when it comes to how do we distinguish between data, software, workflows, environments, and whatever might come after that. How do we actually make sure that a data set that has been deposited gets registered as a software at DataSite and doesn't just be subsumized under datasets like it's happening now? When you're trying to deposit code, it won't be recognized as software, but as a dataset. How do we output the JSON LD hints for the search engine optimization on the Dataverse landing pages? They are currently datasets only. So there might be some things in the back that are obstacles to create these things, and we should talk as a community about how to address that. So I try to summarize a bit of my learnings from the past of what I've looked into in terms of how Dataverse works now. And to me, it's like Dataverse would be protons. Like, you have positive energy, you have a data deposit, that's great. And it's reusable, it's made up of files. You can reference it as an entity, as individual parts. They might be even referenceable by file PIDs. And all of this is coming to the conclusion of, well, it's data and it has just a data context. I'm aware that the workflow working group of Harvard Data Commons is trying to change that, but let me continue here first.
Oliver, 2-minute warning.
Thanks. Datasets could also be kind of atoms. Like, you could have features of a data set, much like the working group already came up with a proposal. You can have a data and software and environments and workflow feature, but there might be larger implications on that with regards to how to distinguish between the different things when it comes to registration of metadata. You could also go ahead and try to create flavors, like datasets could be hadrons, so variants of protons. That would be a huge advantage in terms of you'll still have one entity, one purpose, and not trying to mash up all the things. So hopefully less repeated things, less things that collision with each other. But obviously that also involves changes, but well, we should discuss what would be the preferred approach for the community as a whole. And what came to my mind about workflows is that I'm seeing workflows more like crystals. Crystals are made up usually of atoms, and they are hard to change, or you'll need to provide a large amount of energy to change them. And so they are kind of frozen compounds of references. Like, you want to have references to all the different data sets and codes and things that are used for your workflow. And so this might be better off, instead of pushing that into a data set, trying to create a new type of thing, like a workflow crystal or whatever you want to call it. So onto new frontiers to keep my time limit. The implementation phase for all this stuff starts after DCM and low-hanging fruit first, of course. And for the more complex things, we should be talking. And my idea was to try to set up such a feature proposal as happened before for external vocabularies and licenses. And we should try to come back together with Harvard Data Commons and the software workflow container working group of JDCC and talk about this so we can get along and aligned with our efforts. So thanks, that's it.
Thanks very much, Oliver. Any questions? Because one from Slava directly to you, Oliver, in the chat.
Do you want me to stop sharing so I can look at the chat? Yeah, maybe that's the easiest one. Let's see. Yeah, Slavo, why not JSON LD Shekel? Well, Shekel sucks at performance, and it's a huge thing. It's going to explode in terms of trying to implement that. I'm trying to do small steps first, and Shekel is a huge thing to do. JSON schema is a much smaller step, much easier to implement. So maybe just come up with that first and leave Shekel maybe to you guys.
But we already have knowledge graph, so we can basically recreate serialization in any kind of standard. So I don't understand why not JSON LD and why not Shekel. It's pretty straightforward.
Well, when looking at your presentation, it seemed like you need a larger pipeline set up to support all the JSON LD things and transformation, etc. And this might be something that is just too huge for many of the Dataverse installations out there. And
wait, Oliver, I would say the way how it's implemented, it's really simplifying things. So all of that is basically coming to us. So we did implementation and we tried to hide details of implementation. So the the benefit of using our service, that our metadata specialists can create mappings without knowing technical stuff. So I disagree a little bit with what you're saying.
Yeah, I'm more of a technical guy, so maybe that's one of the differences here. For example, like when you have we have an API to deposit things now, and this API is JSON based. So it would be nice to have just a JSON schema, like for example Zenodo has, to verify, hey, this JSON is what I need to deposit this. So we can also have a backward compatible way of ensuring that people still can have the requirements for metadata to deposit things, because there are a lot of integrations out there that might make use of that before trying to incorporate JSON LD support. Like the native Dataverse API isn't going away anytime soon, I think. And OIE Aura interfaces are still experimental, etc. So maybe we need a kind of a step in between, which could be JSON schema, which is a more or less straightforward thing to do. It's quite easy to transform that necessities for data set fields into a JSON schema.
Did you try semantic API?
Yes, I did.
So why it's not suitable? I think it has all functionality that we need.
Yes, of course. And we actually want to use that, or we're looking into trying to use that with Hammers, but it's experimental. So we want to make sure that also older installations can use this, can use Hammers. So at least we need to make sure that we have the old native API way of depositing software metadata, and maybe add the OIE Aura backend stuff.
Well, perhaps there are some more questions in the chat. Perhaps, Oliver, you could answer them while.
Sure. Let me get Slava asked about JSON Shekel. Okay, fine.
But sorry, we should get going with the next presentation.
Okay, yes.
Time constraints. Yeah. If you can, during the next presentation, just reply to some of these questions on the chat, please.
Sure.
Thank you, Jose. As always, yeah, we'll continue with our talks, but feel free to ask questions of our presenters in chat, and hopefully we can keep that going as well. So please now have co-presenters John Huck and Caitlin Newson speaking about their project One to Beam Up, migrating a Dataverse repository to a shared installation.
Great, thank you very much. And so, yes, our presentation today is called One to Beam Up, migrating a Dataverse repository to a shared installation. And just to give you background, the University of Alberta Library launched its Dataverse service in 2014. And in 2020, it decided to join the National Dataverse Service in Canada called Borealis. or now called Borealis, and this is operated by Scholars Portal. So this presentation will tell the story of our migration and how we migrated our repository to Borealis. Next slide, please. So if only we were living in the world of Star Trek, we would have been able to just simply beam the repository from Alberta to Toronto. But because we are not, we had to rely on other technologies. But on the bright side, we did manage to avoid transporter malfunctions. So I'll start by giving an overview of the U of A Dataverse. Caitlin will talk about Borealis, then we'll give an overview of the migration before addressing specific aspects and ending with some suggestions for future enhancements. Next slide, please. So just to give you a very basic idea about Dataverse at U of A, as I mentioned, we launched in 2014, and by the time of the migration, we had a bit over 550 data sets. And you can see from the bar chart on the left that there was strong initial uptake in terms of deposits, and then dropped off a bit, but was steady but moderate growth for the past few years. And on the right, that just gives an indication of the breadth of the types of data that we had in our repository. Next slide, please. So just to go into those numbers a little bit more, you can see that we had just over 500 published data sets, but we also had quite a large number of unpublished data sets, as well as a large number of unpublished collections. And the fact that we had quite a large number of collections in total, which you can see was close to 200, with a base of about 670 users. That relates to the service model that we were supporting, which I'll talk about on another slide. Next slide, please. And just to give you an idea of how our deployment was set up, we had a production server as well as servers for staging and deployment. That's just kind of some basic facts about them. The bottom line was that our Dataverse was just a little bit under 100 gigabytes in size. Next slide. Okay, so then just touching briefly on the context for our decision to migrate. I think that, first of all, it was not something that we really would have been able to consider before Scholars Portal began offering its service outside of Ontario, which I'm sure Amber can give you exact date, but it was around 2019 when this started to occur. And so that really was a kind of a chance for U of A to take a look at its own service. And so there was an internal report that was created, which looked at just what our costs and staff involvements were in terms of operating the repository, and then compared it to the features that were available on Borealis, both current and anticipated. And the report basically concluded that there was not a lot of value that was being added by us supporting our own standalone installation, and that in comparison, the cost of subscribing to Borealis and participating in that service was economical. So then there was another issue that came along at the same time, which was really in parallel with the decision to make the migration, which was that there was a process that got underway on our campus to centralize IT infrastructure. And so this resulted both in fewer library IT staff that we knew we weren't going to have as many to support a Dataverse installation in the future. And I think it also changed the strategic priorities of the library in terms of the infrastructure that it wanted to support. And so the fewer kind of platforms that it was responsible for running, the stronger case that it could make to hold on to some of the really core ones like the ILS system. Okay, next slide. I think it's over to Caitlin now.
Thanks, John. So Scholars Portal Dataverse is officially renaming to Borealis on June 23rd, and we're the National Canadian Dataverse Repository. We started our repository in 2012 for Ontario universities, and as John mentioned, we expanded nationally for Canadian universities and research organizations. We have our repository available in both English and French, and we currently have over 5 terabytes of data and 8,000 published data sets within the repository. So it is a multi-institutional repository, and we currently have around 60 subscribing institutions. New institutions can sign up for the service through agreements with one of the 4 Canadian library consortia, and each institution has its own collection located underneath the root collection, and administrators from each institution are given admin access to manage their own collection. Each institution decides on their own deposit and permissions models, and they manage the service for their users. We also support user authentication with standard accounts, as well as single sign-on through the Canadian Access Federation. So for this project, we migrated data from U of A, which was on version 4.20, to Scholars Portal on version 5.1. So this migration was happening before the migration APIs existed. So that does frame some of how we did the project. The scope of the migration included collections, datasets, files, user accounts, and permissions. And some of the things that we didn't migrate over, largely because they weren't possible to be migrated, were things like metrics, file level DOIs, and deaccession datasets. Throughout the project, we tracked all of the different tasks and issues and conversation points that came up on a shared Trello board that everybody had access to. And we used Google Docs for various pieces of our documentation. So initially, the team met on a weekly or bi-weekly basis, rather, and then we moved up to weekly as we got closer to the final launch date. So of course, these projects don't happen without teams on both the side of Scholars Portal and U of A. On the Scholars Portal side of things, we had myself, we had our Dataverse Service Director, Amber, our programmer, Victoria, and support from our systems administrators, Bikram and Sohaib.
And on the U of A side, we had a number of staff, many of whom had been involved in operating Dataverse for a long time, and had been through several software upgrade projects together. So the technical staff was very familiar with the Dataverse repository software. Next slide. This gives you a general idea of the timeline, and we'll go into a bit of detail about some of these specific items, but it essentially took about a year to complete this project. We kicked off with a meeting in November 2020, and then the first 6 months of 2021 were basically getting set up, creating migration strategy, developing the scripts, and by July we were ready for a small batch migration on the test server at Borealis. And then we were able to evaluate that and do some additional work in August. In September, we were beginning to, plans were coming more into focus. We did work on data preparation. U of A sent out some initial user communications at that point. By October, we were doing more testing, which I'll talk about more in a minute, more user communications. The final timeline was beginning to come into focus, and we completed the migration in November. Next slide, please. Okay, so now we'll talk about some of the specific issues we ran into. And this one was an interesting problem that we ran into. There was a difference in the permission models between the two Dataverses. And this related to the fact that the U of A service model up to this point had been very hands-off. So most of our users, we gave the ability to create data sets and Dataverses in the root Dataverse collection. And what we realized was that if we migrated those roles as they were to the new system, this would cause a problem. And users on Borealis, because our users would be able to create data sets in other users' collections at that point. And the reason for this is because Borealis had the role inheritance setting turned on, whereas U of A had it turned off. And this was because Borealis, it needed to be that way so that the institutional administrators had the ability to manage all of the content in their institution's collection. So U of A went away and we thought about this, and our solution had a few steps in it. The first thing we did was to move all of the data sets that were in the root and that were not in some other collection into a new general purpose collection. And then to give all of our users the dataset creator role on that new collection. We were then able to remove user roles from the root collection, and we left anyone who had a collection, as the admin of that collection. And so in this way, we were able to preserve the status quo and solve this problem with the role inheritance with the intention of revisiting our service model at a later time. Okay, next slide, please. The other big issue worth talking about was managing the DOIs through the migration. And we really had the goal of preserving the original DOIs through this process. And the one constraint here was that U of A needed to retain its DataSite account. So we couldn't just transfer the account or transfer the whole prefix related to the DOIs in our Dataverse. Instead, we had to create a list of all the data of all the DOIs for the data sets, and then transfer ownership of them individually. And so DataSite, we worked with DataSite, and they were able to do that on the first day of the migration. So once that was in place, it meant that when Borealis ran scripts to push metadata updates to DataSite kind of after the migration, that they had that ability to make those updates because at that point the DOIs belonged to them. For the deaccession data sets, there was a small number of these, and U of A retained those DOIs so that we can take care of tombstoning them. The other big thing that we had to work through was file level DOIs. U of A had about 1,500 of these, which had been created I guess when that feature came along. We realized that it wasn't really a priority for us to preserve those, and it was out of scope for the migration because it was a feature that was disabled in Borealis. And so what we decided to do with those was to use the DataSite API to update those DOIs so that they would resolve to the DOI of the parent data set. So it's not ideal, but it does get the users as close as possible to the original resource that the DOI was supposed to refer to. And we're in the midst of cleaning that up. Eventually those DOIs, I think, will be transferred to Borealis, but there shouldn't be any need to do anything else with those DOIs at that point. And probably the number of times that file level DOIs are being resolved, I'm guessing, is going to be fairly minimal. Okay, next slide, please.
2 minute warning.
As Caitlin mentioned, Borealis participates in the Canadian Access Federation in order to provide shibboleth authentication for the institutions that use Borealis. For the U of A, what we had to do on our side was basically just to work with our campus IT to go through the process of joining CAF at the institutional level, and then through some additional IT processes to streamline the shibboleth handshake for our users. Next slide.
Okay, so the migration of the data for the project was done with a combination of scripts that handle different parts of the process. These scripts were developed by our programmer, Victoria, who's also joining us for today's session. In case you have any questions you want to post in the chat. These scripts don't make use of the migration APIs, as I mentioned before, because they didn't exist yet. So the scripts are written in Python and made use of the PyDataverse module. Before starting the scripts, a configuration file is set up that points to the correct storage paths and databases. Data files are copied over to our server using rsync so that they can be imported by the scripts, and the Python environment is set up on the server as well. So once those pieces were in place, then the scripts could be run. The scripts are broken down into different parts of the workflow. They're designed to pull data from the U of A repository, such as the collections and data sets, and then import these into the new repository. For example, there are scripts that handle collections, that create user accounts, upload data sets, and add user permissions. After the imports, another script updates the publication dates for dataset versions so that they match what was in the previous repository using JSON data that was generated from SQL queries. After updating those dates, the script pushes this updated metadata out to DataSite, since this doesn't happen automatically if you make direct database changes. And we do have all of these scripts available in our GitHub repository, which I've linked in the slide. And they're also linked now in the official Dataverse documentation on the apps page, which I've linked to as well. So after running the scripts, there are some additional system tasks. An additional script is used that compares data sets between the installations to make sure that everything's been migrated over. And then another command is run to clean up all the cached metadata files that are in the storage to make sure they reflect the updated dates. And then lastly, we would re-index everything to make sure all of these dates are appearing in the UI as well.
Please try to wrap up.
Okay, so I'll just go over the next few slides briefly because I've got my eye on the time. We did 3 rounds of testing. As I mentioned, there was a small batch migration at the beginning. And I think the main thing to say there is that was the opportunity for U of A to realize that the original publication dates associated with data sets would not be preserved in this migration process. And we considered that and considered the impact that that would have on data citation and decided it was a priority for us. And so made the request, and Scholars Portal very kindly developed additional scripts to update and the publication dates within the database so that we could have that continuity of original publication dates. We ran a full migration on the test server, and that uncovered an interesting time zone issue that affected the publication dates, which I won't describe now, but we do have the details if you're interested in that. And then finally, there was a small batch migration on production just before we did it for real in order to test that transfer of the data set DOIs. Okay, next slide, please. And again, I won't say too much about user communication here, except that the initial communication that we sent out, we wanted to emphasize the things that weren't changing, the benefits of the change, and using a format that would present questions that users would probably have. And then we were able to send out 5 days notice ahead of time that the users wouldn't be able to access the data, our Dataverse at that point. The data was going live immediately on the Borealis platform, but we needed to prevent users from accessing the platform at U of A so that nothing was changing while the scripts were running. We're happy to say there were no significant issues that we ran into from the user point of view. Next slide, please. So here is just a before and after, and so yeah, that's about all that there is to say. We were able to preserve the look and feel, obviously, of U of A, and we're very happy to be part of the collaborative community now at Borealis. Okay.
So we'll just wrap up with a few things that could make future migration projects like ours a little easier for other Dataverse installations. We do now have the migration APIs, which could be further developed to handle all of the components of Dataverse datasets, like permissions, metrics, locations, and collections, and multiple versions of datasets. And the last I wanted to note is just that the ability to import file DOIs would be useful for any installations that are using them, because they can't currently be imported, but this is also captured in GitHub. Thank you.
Well, there's only been a raised hand from Victoria. I believe she has now the permission to speak. So go right ahead, Victoria.
No, I didn't. It's just by mistake.
Oh, okay. So does anyone have any question? You can put it here on the chat. If not, perhaps we could move on to the next presentation, and then, if possible, any questions will be answered here in the chat also.
That sounds good. Yeah, we'll move on because we're running a little short on time. So our next speaker, we have Eugene Varsky talking about the Dryad to Dataverse software. Eugene?
Thanks. Obviously, I forgot to click the unmute button. Good to see so many familiar faces for those who I see and names in attendance. I want to take a second to thank Harvard team to run the meeting this year as virtual, and thinking about how much carbon emissions we have saved as a community, and enabled me to go to work on my bike and not fly across the world. So thank you for doing it. And during the last 2 days, you have seen so many cool integrations with the Dataverse software and other tools. So I would like to show you one more, focusing this time on the Dryad platform and its integration with Dataverse. So my name is Eugene Varsky. I'm a research data librarian in the University of British Columbia, and we have been working with Dataverse for quite a while. Since 2014, we were one of the first users. My colleague Paul Lissac is the data analyst and a developer in our team, and he is the main lead for this development. But Paul is on vacation and enjoying himself by a lake in Ontario, cottage country. So I am here to talk about this integration. But tomorrow we have a recorded session with myself and Paul, so you can see and hear his voice as well. For those of you who want to experiment as I go and talk about this integration, I did post the code and the documentation and the end result in the chat. Click some buttons, play along, and ask questions at the end. And I will try to reset us with time. I don't plan to take as much time as planned, so hopefully we'll give the German colleagues some more time, especially because it's really late in the evening in Europe already. Thank you for staying late. Okay, so Dryad to Dataverse is a tool to facilitate the translation and harmonization of data between Dryad and Dataverse from start to finish. It's a downloadable piece of software, a standalone, and a development tool that we want the community to know of, especially many of those institutions that are using Dataverse software, and they have researchers depositing data in Dryad. And we hope it will be interesting development for the community. UBC is a large institution based in Vancouver, British Columbia, Canada. We have more than 65,000 students, thousands of faculty. Our primary research data repository is in the Dataverse software. We have around 1,000 data sets. And over the years, we noticed that many of the UBC researchers publishing data elsewhere. They're publishing data in other repositories, obviously, but a lot of them are publishing in Dryad, which is a major repository in the natural and life sciences. And while we liked it, we also wanted to bring the collections together and to allow data preservation and enhanced discovery. And the reason to enhance discovery, because we have another product that we developed in-house called Geodesy, another open source software that allows geospatial discovery for data. So it really puts the research data from our repositories on the map. If you haven't seen it, we have presented about it last year and the year before, and it's active in the URL. I will post in a bit, or John can post in a bit in the chat. So we could have done it manually, obviously, but we are talking about hundreds of data sets, and it will be a painful and slow process. It would be less data loss and human error if we did this work programmatically. All materials in Dryad are licensed with CC0, which means we could experiment and play with them from the legal point of view, which we did. Our software that we had in mind had to be simple, to be used by people with no huge programming experience, like myself. Like I'm listening to Slava's talk and I only understand half of the technical terms. So we didn't want to do that. We wanted to have a simple software that will be used by anyone and could run with the command line and could be scheduled in specific intervals. We all know that the Dataverse software has an excellent API, Dryad too, and we wanted to have a programmatic approach that will sit between the two APIs and transfer data to harmonize the collections and with a small database that monitors the changes. So let's get to it. So how did we work through the process? First step, obviously, create a metadata crosswalk. Most of the attendees in this session are very much aware of crosswalk is. In my opinion, it's the most important step. We had a rich experience working with crosswalks. We developed software before. We migrated Dataverse from 3.x to 4.x to 5.x, and also we created Jodeci. So it was a relatively painless experience for us, but Dataverse JSON is complex, as we will see very soon. We wanted to use native JSON as an import and not Dryad JSON. It's more complex, but it allowed that complete control of what goes where, which was not possible if you use schema.org JSON or DDI. And off we went programming. So the software that I showed again in the link is a Python-based. It has limited dependency on external libraries. It can run by itself. It's for people who don't really like programming, like myself. And it has 3 parts: a serializer module, transfer module, and monitor module. Let's start with serializer module, the most important one. It connects to Dryad's instance and converts the Dryad JSON output to Dataverse JSON output. That's the crosswalk. It also includes the files JSONs for I will explain why in a second. As we know, Dataverse JSON is a complex hierarchical structure, and it's not really a human parsable JSON, but it allowed us full control of where to put things in a Dataverse software. The next module is transfer. Transfer does require privileges. So you need to be able to write into your Dataverse storage, which we were able to. But if you decide to use our software, you should be able to have access to storage writing. The transfer is dependent on a serializer, of course, because we copy the entire Dryad study from a Dryad to Dataverse using the mapping provided by the serializer. We put a copy of Dryad's JSON in the record as well, so the comparisons can be made at any time when we need it. It moves the files as is, as much as possible, and Dataverse unzips files by default. And we try to mirror the Dryad structure as much as possible too. The last module is monitor. The first 2 modules can be run by themselves, by the way. They're fine for one-off transfers if you just have to move things around. But we wanted to support flexibility and dynamics, because Dryad studies, not unlike Dataverse studies, are dynamic. They're not constant. And to track changes over time, we must be able to see the previous state. So we use a simple SQLite database that stores Dryad and Dataverse metadata and monitors file and metadata changes, so both file and metadata changes. On a weekly basis, we produce a report, and we work from that report. And in conjunction with the transfer module, we can update the material that has been transferred already or is going to be transferred. Some features of the software, again, you can experiment with it. Meanwhile, it's quite well documented. It's a command line program to convert, upload, and monitor studies from Dryad. It's a self-contained program. As I mentioned before, each run of the software creates a timestamp database backup, so we can go back to it. There's an option to skip problematic studies, to put them in exclusion list. I will explain in what kind. It does not require any particular platform or any specific privileges, except the capacity to write into local storage. So you have to be at least have dataset creator or curator to run the software. It's not perfect. It cannot be perfect because we do it on the side of our desks on top of our jobs. So it has limitations. One of them is size. Many of the Dryad studies are large. They talk about natural science and life sciences. Some of those studies are quite large, and we cannot easily use we cannot easily upload them to the Dataverse software. So it did affect around 2% of our studies, but we had to comply with the maximum upload size. So those studies were, for now, put on exclusion list until we find a better mechanism to work with large files. Again, we are talking about maybe a dozen studies. By design, studies are not published. It allowed us a manual curation step where I can go and review the studies, suggest some changes, fix things, add metadata, and publish them manually after. We do it on a weekly basis. And it does not track changes made on the Dataverse side. So it's one way only, Dryad to Dataverse and not Dataverse to Dryad, just to keep in mind. That was the purpose of the software. If you haven't looked yet, give you some links. The first link is the end result of how things look like in the Dataverse software. The second link is the code, and the third link is documentation for the code, where we describe how things will work for you step by step. And lastly, our contact info. Paul and I both working with this software on a weekly basis, very much familiar with it. Give us a shout if you want to experiment and play. It's open source, license under MIT license, and free to reuse. I will stop sharing and take questions.
Thank you,
Thank
Eugene.
you.
If anyone has any questions, please insert them now in the chat. If not, we can go on to the next presentation. And Eugene, if possible, will answer any questions in the chat that might appear.
Sounds good. And hopefully we reset some time here.
Yeah, I think you did. Thank you, Eugene. All right, next we will move to our next talk. We have Jan Range joining us from Stuttgart to talk about Easy Dataverse, generation of a user-friendly Python interface to a Dataverse installation.
All right. Hi, everyone. Thanks for the kind introduction. My name is Jan Range. I'm a PhD student and research software engineer from the University of Stuttgart. And it's quite interesting. It's my first Dataverse community meeting. So first of all, huge thanks to you for the invitation and to be part of this as a presenter. It's a huge honor to me. Also, one thing, the previous talk, it's very similar actually what I will be presenting now right here. It's about Easy Dataverse, which is a library that I have written and to accommodate some problems that I've had or challenges when I was starting to work with Dataverse. So first of all, I would start with my motivation, why did I do what I do and what were the challenges I've had with the current workflow. After this, I will present to you the library PyDaros, which is actually kind of very tightly bounded to Easy Dataverse, which is actually the topic right here. And well, after I've showed you the workflow and also what Easy Dataverse actually is, to wrap everything up, I want to give you a small outlook. All right. Now, to start with, if you want to, I think every one of you is aware of that. When you want to upload something programmatically towards a Dataverse installation, you have multiple options. You can either do it by HTTP requests, use it in shell scripts or via the terminal, whatever you like. If you happen to use Python, you can use PyDataverse, which I did extensively since I was starting with Dataverse, which is a very great package which was written by Stefan Karsberger. Now, both of these approaches have in common that they require the Dataverse Json format. And as already pointed out, this is not really an easy format by itself. It not only includes the metadata blocks and the data that we want to put onto Dataverse, it also has information about, I call this implementation in a way. Implementation means several fields that tell Dataverse installations, such as multiple field or the field type. Now, if we inspect such a field, we see that it is just not the value right here. Here's an example. I just want to put a name to an author. In this case, I just want to put my own name right there. But it's a lot more required to do that. First of all, we need information about whether this field can exist more than once. Also, what you have to specify is the type class. There are 3 types present. This is, first of all, the primitive one, which is a very easy one. It's just a simple mapping. In that case, the compound, which can have more primitive fields. And last but not least, also the controlled vocabularies, which are kind of an enumeration for standard values. What you also have to provide is a type name, which is not always the display name. It is derived from the TSV files. And last but not least, you have the actual value, what in this case is my name, which I'd like to assign. Now, if you view this from the user perspective, me as a user, when I started out with Dataverse, I was just interested in putting my name to this author compound object. But the implementation requires myself to also provide all of these implementation details, which are important, which are necessary to have a successful upload. But this raised some concerns from my side. Like the problem is like that the normal user that wants to integrate Dataverse to their software or applications such as Jupyter Notebooks, they might not be aware of these implementation details, because sometimes, I mean, when the metadata blocks that are present in a Dataverse installation, they are not publicly available. I mean, to some extent, people will fail and will have a hard time to actually do this and produce this and have a successful upload at the end. And yeah, as I already mentioned, like the user is really interested in just mapping from name, for example, to the fields at the end. And this raised 2 questions from my side. Now, can we simplify this programmatic access for the end users so that they don't have to deal with all these implementation details? But how can we still be compliant towards Dataverse? Now, this was what I was requesting to myself, was to have kind of a Trojan horse in that way, where the Trojan horse is a simple software which in its core provides the Dataverse JSON, what the user doesn't see. And what I came up with is the library PyDaros. PyDaros is a Python library which gives you access to Daros, the Dataverse installation at the University of Stuttgart. It has already applied to various topics that are present in our university, one of which is where we conducted experiments on simulations, made them reproducible through Dataverse, but also on the report of biocatalytic experiments or small angle X-ray scattering. What PyDaros essentially does is that it implements all of the metadata blocks that are present in Daros as objects. These are class definitions, and these class definitions use a Python library called Pydantic, which is an insane, really, really nice, great library that I happen to use quite a lot in my other works. And what this allows is that we can add metadata to these attributes. And in the next slide, you will see why that makes sense. What PyDaros also does is that it supports, of course, the upload, download, and update of data sets. And on top of that, you can also import and export these data sets to various data formats. Currently, JSON and YAML and HDF5 are given, and the output is much more readable than the Dataverse JSON. And yeah, for the end user, this could be something that helps them to understand the data set much better or to share it with people. Here you can see a tiny fraction of the implementation of the citation metadata block. See right here we have these attributes. In this case, it's the author. It has, of course, a type annotation, but here comes the pydantic magic at the end. Aside from the description, we can also tuck in all of these implementation details. And the cool thing about that is that the user doesn't really see that. The user doesn't have to care about that because at the end it is molded inside of this this class definition right here. And on top of it, something to make the life a bit more easier, we've also added dedicated add methods, so you can add these compound types which are made of multiple different primitives, easier than just to import author in that way. It's just to make life a bit easier. So how is the workflow when you're working with PyDaros right now? Of course, at the beginning, you're going to import all the necessary things, which are, of course, the metadata blocks that you want to use, and also the dataset object. We also support enums that are essentially the controlled vocabularies that you can also use and assign later on. After that, you initialize all of these objects, and at this point, everything is quite empty. There's nothing really happening inside, and the next step is what gives everything a life. This is where we add the metadata to each of these blocks, and you can do this in the normal object-oriented fashion in a way. You just assign values or strings to these attributes. One cool thing right here is that there's an inbuilt validation that comes from Pydantic, which makes sure that, well, when this needs to be a floating type, you cannot add a string. So there will be an error message that you did something wrong at this point. And yeah, from this point, you just add everything. You can use these dedicated add methods to each of these metadata blocks. And when you're done with that, you also have the option to add directories or files. In the case of the addition of a directory, the files and also the directory structure that is found in these in this directory will also be projected towards Dataverse. If you want to manually specify where it should be at your data set in Dataverse, you can also do this by the normal add file method. And when you're done with that, you're actually already finished. The only thing you have to do now is to add each of these metadata blocks to your data set, call the upload function and specify to which Dataverse you want to upload it, and everything will be done for you. In the backend, PyDataverse is working. Some of you may recognize it already from this first string right here. And when we then want to inspect the data set, everything is there, all the files are there, the metadata, and we're happy. Of course, PyDaros also supports download and updating of these data sets. When you download a data set, these metadata will be transferred to this data set object, and the files that are present in this data set will also be saved in any kind of user destination that you specify. From this point on, you can change the metadata, add more metadata, change files, add files, and update everything as beforehand. So you can kind of like, this is an application that we have as well. We have one certain application, let it be a simulation. It produces some metadata, and in the next script, we want to work with more of an analysis type, and this further adds metadata and files. So you can reach everything through these kind of steps in a process. Another thing that you can do is that you can initialize these data sets. These are currently supported from YAML, JSON, and HDF5. Here on the right, you can see such an initialization file. This is quite nice for templating, because if you have periodically a release, let's say for a software release, well, there might be a lot of authors and some other metadata that actually doesn't really change. So you can keep this template right here, mutate it to the way that is best for your new release, and just initialize the data set and you're done. One last note is that PyDaros fetches the credentials from the environment, especially since PyDaros is meant to be used in applications such as scripting or in Jupyter notebooks and so on. And there you really don't want to push your API token. This is a bad practice, and it's also a security concern. So in this way, you can dump everything in your environment and you're good to go. But at this point, I have to be honest with you. I didn't write PyDaros by myself, and neither did any human being write PyDaros, because PyDaros is actually generated, and this is generated by using EasyDataverse. This kind of closes the circle right now from this presentation. And EasyDataverse is actually the Python library that I have written that has two main purposes. First of all, of course, the API code generation, but also the induction of functionality. Now, the API code generation works in that way that the API generator reads all these TSV files that are present. At the moment, this is done locally. So if you have to store them somewhere, but you can also run this in a CI/CD pipeline. It just has to have access to these TSV files. And what it then does is that it generates these class definitions that are essentially the metadata blocks. And on top of this, it also generates a Docker file for a more simplified REST API way, just doing the key to value mapping, what the user is interested in. And also a comment on the CI/CD optimization. We are already experimenting with that. It's not officially out yet, but it works. So whenever we change something in our TSV file, we add something, a new API will be generated and pushed towards the official GitHub repository. The other thing that EasyDataverse does is that it induces functionality. So actually what PyDaros is, as I've already said, it's just these the class definitions of these metadata blocks that we're using at Daros, nothing more. Only in the combination with EasyDataverse, and this is actually the data set that we've imported beforehand in the example, all the functionalities such as upload, download, and update, and these export and import functions all come from EasyDataverse themselves. So I thought about when I was writing this, that this design is quite handy to have, because actually we don't want to change our metadata blocks and change them manually. We want to keep them really, really aligned to the TSV files. And actually it shouldn't be touched if nothing of this changes. But whenever we want to add some functionality such as validation or visualization, whatever you want, we can change it at EasyDataverse. And at the end, it will be reflected onto all the other APIs that are using EasyDataverse. So everyone has a benefit of that. And with this, I also want to close EasyDataverse. This is actually everything about it. It is quite lightweight. It's not that big, but I hope you got a good impression of that. At the end, a small outlook what will happen in the future. I mean, this project is quite young actually, and it was actually born from me being lazy to write the Dataverse JSON, and I wanted to have something more convenient in that way. And thus there needs to be some more development, such as bug fixing, writing tests, and documentation at this point. Also, we want to extend the functionality towards custom validation in combination with reports by using Python functions that any Dataverse installation can use by themselves, whatever they like, such that the reviewer has an easier time on fields that are optimizable. One thing that I also want to work on is, and this might be an obvious flaw right now from PyDaros, is that, well, I just can't download anything from another Dataverse when it uses different metadata blocks. And that's why I want to work on to create these classes on the fly, such that I can just say, okay, let's take EasyDataverse, download something from the Dataverse in Delft, for example, and whenever I download that, based on the Dataverse JSON, it will generate in memory a class for that, such that I still can use it in this object-oriented way. Obviously, you can't upload it because some information is missing, but in this way, we can download from everywhere. And last but not least, for the code generation itself, we at the University of Stuttgart, and especially at SimTech, where I'm working, simulations are currently, most people are working with Python, but we also have a strong base for C++ and also for Java. I'd like to write a code generator for these programming language so that they also benefit from that. And with this, I want to close and thank you for your attention, and I'm open for your questions.
Thank you, Jan. We're actually going to go right into our next speaker just because of time. And hopefully if people have further questions, I know there's been a lot of appreciation for the excellent work you've done already in the chat.
All right.
Okay. So we will move into a round of applause for Jan, and we'll move into our final speaker. Dorothea is joining us today to talk about, let's see, Dorothea, you do have screen control, right? Yeah, sorry, joining us also from Stuttgart to talk about metadata to Dataverse.
Yeah, so this is also some other small tool from the University of Stuttgart, and yes, Jan, and we are talking to each other, but it's still something similar. Okay, as Jan has already talked, we are a part of the research data management team of the University of Stuttgart. We operate Dois, one of the Dataverse installations in Germany. We are a technical university, so our researchers have really a lot of data, and we as a research data management team request them to add really a lot of metadata to their data sets. So all the it becomes an issue. Automation of metadata capture becomes an issue. And as we have heard a lot today, there's an API for Dataverse. You need a special JSON format to create, to update, to edit. It's easier if you use the edit API endpoint. It's perhaps much easier to if you use a JSON LD endpoint, as Jim has pointed out, but yeah, we are slow, and we started when this wasn't existing. Okay, we need information about the metadata configuration in the TSV files to do this. And metadata to Dataverse now has a bit another approach than Easy DAOs or Easy Dataverse by extracting existing metadata information in existing structured formats, like so far in XML, JSON or text files, like something like code meter files, like something like a data site in meter and XML, and converts this to a Dataverse compatible JSON. At the University of Stuttgart, we have some additional metadata blocks. We have some engineering metadata basing on ngmeter. This is an XML XSD based scheme about the research process, used methods and tools, and also about what the object of research was, components, variables. And we have a metadata block for research software basing on code meter. This is extremely similar to the one that Oliver pointed out. That is a pull request already in the Dataverse community. And now what we did is just a small REST API basing on Python Flask that does a mapping from one structured metadata format to the Dataverse JSON format. I will now further on concentrate on the metadata endpoint. This is the one who does the real mapping. We have other endpoints that manage the mapping files between the schemes, and also endpoints for handling the configuration, metadata configuration of the Dataverse installation. The code is available on GitHub, also together with the Docker file and the GitHub action. And it's authored mainly by my colleague, Annette Seeland, who's also here in this session, and me on a conceptual way, and our students, Anne Kreuter and Usman Mirza, the implementation. Okay, what it does is just you post a metadata file of a specific type. So for example, a code meter file to the metadata to Dataverse post endpoint, specify the scheme you have, and you get back a Dataverse compatible JSON that you can use then to edit, update, or create a data set on Dataverse. Metadata to Dataverse depends on the TSV files, so it's independent of an installation. You can just add your own TSV files to have here this adjusted to your installation. And there are a bunch of mapping files that define the mapping from the one scheme to the other scheme. They look a bit like this. So the YAML file that just defines where what metadata format we have, an identifier for the mapping, and then mapping information about from which source key the information should be copied or merged or rule-based transfer to which target key in Dataverse. As a scientist, so far, only as a scientist at the University of Stuttgart, could use metadata to Dataverse just manually by from the command line by a curl command, just calling these endpoints, or also within your scripts, perhaps in combination with PyDataverse or PyDAOs or something like this. And also we have implemented so far by Katharina Gönner as a GitHub action for a specific use case I will come to if I have a little bit of time at the moment. If you would like to have something like this, you could use just your own metadata configuration, your own mapping files for the metadata files of your researchers and deploy your own instance of metadata to Dataverse. What we have implemented so far are mapping files for CodeMeter and EngMeter, so for our special metadata blocks that are also available on GitHub and are the source of easy PyDAOs that Jan talked about a few minutes ago. One really special use case comes from one of our research software projects with the idea that if you are a researcher who develop software and have this versionized in a Git repository and have already added a metadata about your software in a CodeMeter file and have this there in your Git repo, you could use the Git action of metadata to Dataverse, configure it with your Dataverse URL, with your API key, and with your the dataset DOI. The action will then build metadata to Dataverse as a container, then fetches the CodeMeter file, translates it to the Dataverse JSON, and then finally edits the existing dataset on Dataverse there. And there would be here a demo, but as there are 2 minutes left for this session, you can see it. I have uploaded the video also to the slides directory, and you could see it in action, how it would look like. And yeah, so there's still a lot of improvement. It's just a prototype. There are the Dataverse metadata configuration REST endpoints are missing. We want to provide also a GitLab action. We want to work with example workflows, how to integrate, perhaps also merge different information from different sources and then merge them all together to a nice JSON file, perhaps support further file formats like RDF. Yeah, think about what to do with mandatory fields and how to provide default values. I think so Slava had a solution for his tool for this way, and perhaps based on your feedback, create other mapping configurations for other metadata schemas, as ours are really specific for the installation of Stuttgart. Okay, and so I could show you some of the functionalities, but I think time is just over, and so I thank you for your attention. I'm open for questions, and then it will be too, for sure.
Dorothea, that was incredible. How quickly you got through it. Thank you. As Jose noted, yeah, this session will be repeated tomorrow. A few of the speakers will be pre-recorded, but we'll try to break up our time a bit better. Maybe we'll start with Dorothea so she can get a proper allotment of time and give folks that demo. We do love our demos.
Okay, we have 1 minute left. Maybe Dorothea can answer Philip Concept's question on the chat.
Yeah, so is there any question? I just see the question from Philip about the customized metadata schemas. So far, the customized metadata schemas are not harvested by any domain-specific repository. so far. But we are a bit integrating, working on integrating this with efforts on the National Research Data Infrastructure in Germany, and then perhaps also with the EUSC further on.
So I think that is it. Jen, over to you to perhaps wrap up.
Okay, great. Thank you so much, everyone, for joining us for a packed session of terrific presentations.